Hey, all you Jayhawk fans, welcome. Hey, you Missouri Tiger fans, not so welcome. But anyway, you can stay and watch. We're going to talk today about in behavior of rational functions. All right, so this is kind of a follow-up to the previous video, but so we're going to use the same function that we used. And when we talk about in behavior, what we're talking about is what happens to the function when x goes to positive and negative infinity. All right, and let me, so when we say what happens to the functions, what happens to the y values is a better way to say this. What happens to the y values when x goes to positive and negative infinity? So let's take a look at the graph. So here we see the graph. Okay, now keep in mind that when x gets big, it's over here and over here. So if we zoom out a little bit, you can see, all right, it starts to level off. And what we have is we call a horizontal asymptote. Okay, so a horizontal asymptote. And you can see there that y equals 1 kind of splits that graph. All right, y equals 1. So y equals 1 is the horizontal asymptote. Okay, so if we keep zooming out, that red graph stays above it here and stays below it here. Right? Now, how can we figure that out? In order to figure that out, we need to look at the function, but I like to look at it it's when it's all multiplied out. So let's multiply that out. So here we have it multiplied out, and so what's going to happen here is this x squared when x gets big, and this x squared when x gets big, they're going to so dominate these parts here. All right, so let's look at an example there. So what I've put here is I put x1 squared, and I've put the rest of this here. So when x is small, when x is 1, okay, notice that this is small compared to this. But watch what happens as x gets big. So I'm going to slide the 1. Oh boy, so I got really big there, okay? But notice what's happening, okay? This number here, as x got big and it got really big really fast, just completely dominates this number here, all right? So let's come down here and let's write 2.025, oh boy, that didn't work, 0.025 times 10 to the 13th, and we're going to subtract 4, 5, 1, 2, 3, 4, 6. So look at that. Even though it does change it a little bit, but it's still practically 2.025 times 10 to the 13th. It hasn't really changed it at all. Okay, so that x squared up there, that whole point of that was that x squared dominates when x gets big. And so this dominates this, all right? And so then if we only focus on the biggest aspect of it, x squared, well, what's x squared divided by x squared? Let me change this to x1 over x1. Okay, what happens? Okay, well, as x gets big, right, you know that that's equal to 1. I'm going to change this. I'll change this to 1,000. Okay, but what's going to happen? It stays 1, and so that's why our horizontal asymptote is 1. Okay, well, let's adjust this a little bit. Let's put 80 there, and let's put, yeah, that's fine, and let's put plus 50x here, minus 9. Okay, now weird things kind of happen, all right? I haven't, so now when I put those bigger numbers there, weird things kind of happen in the middle, but notice as my x gets big, all right, now the horizontal asymptote is still the same. See, out here it's approaching 1, and here it's approaching 1. Even though my numbers got bigger here, okay, Still, what matters is x squared over x squared. Okay, so let's adjust this a little bit. Okay, let's go back to some more normal numbers here. Okay, go back to some more normal numbers here. Here in the middle, weird things happen, but out on the end, it's still going to 1. All right, let's make this x, make that x cubed. Okay, now my horizontal asymptote has changed. You see this gap here? All right, I'm going to say, so what happens here when I make this a 3, because that's all that matters. Right, now as I make my x values bigger and I creep towards 1,000, what's happening to this number here? Well, now it's going to 0. Hopefully that makes sense. It's going to 0, and you see it there now? All right, now my horizontal asymptote is more accurate. All right, that number is getting closer and closer and closer and closer to 0, as you can see here. Let's adjust this. What happens if this goes to, say, the 4th power? All right, well, now this is increasing without bound, and this is decreasing without bound, right? And so we will talk about this now, all right? And I'm going to take this out of here, and I'm going to jot, let me put to the 4th power here, all right? And now what happens? Well, that number just keeps increasing, right? As x increases, our y value increases. And so when the numerator has a higher degree than the denominator, we say it has an oblique, sometimes a slant asymptote. It no longer is horizontal, it's a slant asymptote. And we'll talk about in class how to calculate that. I'm not going to show that to you here. But we'll do that in class for a couple examples. All right, so that's a little bit on end behavior of rational functions, right? Remember, that's what happens to the functions when x goes to positive and negative infinity, right? It still uses, okay, we still use the term asymptote, but that only is for x values large enough. Let me say this, whose absolute value is large enough. All right, hopefully that makes sense to you. If not, ask questions in class. We'll see you then.